Aurora Borealis could dip into the northern US this weekend for solar flare geomagnetic storm. Much of New England, the upper Midwest and the northern tier may see the dancing northern lights. Bright auroras may illuminate the dark skies over the northern United States this Halloween weekend. On Thursday, the Sun launched a major X-class solar flare, sparking a high-frequency radio blackout across parts of South America. That same pulse of energy is trailed by a coronal mass ejection CME, or a cluster of solar plasma and material surfing an interstellar shock wave. The CME, the strongest of this solar cycle so far, could slam Earth and whip up a stunning display of the northern lights. A CME from a similar position spawned beautiful auroras on October the 12th. NOAA's Space Weather Prediction Center in Boulder, Colorado, is warning of a potential strong G3 geomagnetic storm that may rock the Earth on Saturday, with effects lingering into Sunday. Storms of that tier can produce displays of the northern lights visible at latitudes as low as Pennsylvania, Iowa and Oregon, and can also have electrical impacts. Voltage irregularities are possible on high-latitude power grids, along with intermittent issues with radio and navigation. Sky watchers in the United States and abroad are hoping for a Halloween weekend treat reminiscent of the geomagnetic storms of 2003, during which the Aurora Borealis shone as far south as Texas and Florida. That spattering of solar flares and geomagnetic storms caused a power outage in Sweden and forced air traffic controllers to reroute flights. NASA's Advanced Composition Explorer spacecraft was damaged. This time, forecasters are able to adequately warn power companies and utility managers of potential threats, allowing protective action to be taken in advance. The hampered high-frequency radioactivity during the flare is the only ill effect of the event so far. Solar flares are like eruptions that hurtle off the surface of the Sun. They're born from sunspots, or small bruise-like discolorations, that throb and pulsate with magnetic energy. When a solar flare occurs, X-rays and other high-energy particles are spewed outward in all directions. We ordinarily don't know about an incoming solar flare until right before or when a radio blackout ensues. Thursday's solar flare was an X-class flare, the most significant classification. It came from NOAA Active Region 2887, a large sunspot group mapped by scientists. Typically, large, expansive active regions are most likely to produce strong eruptions, as they draw magnetic fields over a broad expanse. These fields provide fuel for the event. Think of it like the sound of a large symphony orchestra compared with a string quartet, the more the better, for energy that is. NOAA 2887 is still hot and in a prime spot for more geomagnetic activity, with more to possibly come for the next 4 to 5 days. NASA's Solar and Heliophysics Observatory SOHO captured the moments that high-energy particles, including protons, bombarded the satellite. The clear image suddenly became snowy, resembling a spattering of streaks and pixelated speckles. Radio blackouts occurred shortly thereafter. Weather satellites, like the GOES series ones that provide most of the imagery relied upon by meteorologists, have noted an increase in the frequency of solar protons, but experts think it is not enough to cause radiation exposure concerns. Behind the solar flare is a more targeted coronal mass ejection CME, which departed the Sun at a speed of 973 km/s. CMEs contained the pulse of magnetic energy that interacts with Earth's magnetic field to produce visible light. If we didn't have a magnetic field, we'd have nothing to convert or deflect incoming magnetic energy into dazzling displays. The Earth's magnetic field is most concentrated near the poles. That's why the Aurora Borealis northern lights and the Aurora Australis southern lights typically appear in a ring around their respective pole. When the arriving CME is more intense, the aurora level can expand equatorward to include the lower latitudes. This time, a belt of the northern United States may see some green hues late Saturday night into Sunday as the energy excites gases in our upper atmosphere, causing each molecule to emit a photon, or a packet of colorful light. There is some uncertainty in exact timing of any aurora. It takes time for forecasters to determine the likelihood of a CME being Earth-directed. Glancing blows can usually bring shows to the Arctic and Antarctic, but a mid-latitude display would require a direct strike. That looks to be the case this time. How to enjoy the show? Northern tier states, stretching from Washington to Michigan to Ohio, may enjoy some overnight color. The prospects of clearer skies will be decent in the upper peninsula of Michigan and over Wisconsin, as well as in the Pacific Northwest. But signs point to clouds lingering over the northern Rockies and northern tier. Folks farther south, more than 100 or so miles away from the Canadian border, have a better chance of seeing monochromatic arcs of light or dull white pillars that appear like flashlights shining into the sky. Clouds will pervade across much of the eastern United States, thanks to a stalled low-pressure system that will slowly wither away over the northern Appalachians. There may be a few breaks in the forecast over Maine, but it's not worth betting on. For the best chance to see them, find a patch of land that offers an unobstructed view over the northern horizon. Make sure you can see the stars, too, and you're not fighting light pollution. Cameras can ordinarily see them first, since long exposures are able to resolve faint light more vibrantly. If you don't see them, don't despair. We're entering a period of increased solar activity, known as a solar maximum, and we can expect to see more auroral activity this solar cycle.